No.
Okay. I was going to show a picture of a phablet. Can anyone tell me what's a phablet? P-H-A-B-L-E-T. It's a cross between a phone and a tablet, isn't that right? It's like a big phone. Have you never heard that before? No. So you guys really need to be on a website called news.com, CNET, alright? And stuff like ZDNet, and reading the news there every day, which I do every morning. The technology news, so you find out what are the trends in the industry that I hope you're all going to be working in. A phablet is a cross between a phone and a tablet. Alright, so it has some of the characteristics of a phone and some of the characteristics of a tablet. So let's say we wanted to try and model this in sort of OO, alright? We might decide that we have a class for computer, which has got loads of different properties, and you know, the CPU speed, the amount of RAM, the amount of disk space and everything. We might decide that we have a class for a phone, because a phone nowadays is a type of a computer, I guess, isn't it? Alright, and we might decide that we also have a class for a tablet. Because these are both types of computers. And why not throw in a different one here for a laptop? So I guess they're all different types of computers, aren't they? Alright, so where does phablet go? Really, what we want to say is, you know, this is a type of relationship here, this arrow in OO, isn't it? This is an is-a relationship in a class diagram. That means that a phone is a computer, a tablet is a computer, and a laptop is a computer. Alright? What we kind of might want to do is we might want to put a phablet down here. P-H-A-B-L-E-T, which is a phone and a tablet. And we might want to say that it's like this and like this. That kind of makes sense? So that means a phablet gets everything that a phone has, and a phablet also gets everything that a tablet has. That makes sense? This is the inheritance relationship. How do we code this relationship in C#? What's the notation that we use?
Inheritance.
We use inheritance, right? And how do I say that a phone is a computer? Use colons, right? So you just go phone, colon, computer, and then phone, tablet, colon, computer, and then laptop, colon, computer. That's how you actually code it in C#. Now this thing here, a phablet, which is basically a phone and a tablet. Can this be done in C#, or how would you do it in C#? Yeah, interfaces is one possible solution. But basically, this type of relationship, can it be coded in C#? How many people say yes? How many people say no? The answer is no. You can't code this. This is an example of, in object-oriented programming terms, this is an example of what's called multiple inheritance. And multiple inheritance, you put a big X beside it because it can't be done in C#. Can it be done in Java? No, it can't be done in Java. So C# and Java, neither of them support multiple inheritance. They only support single inheritance. Single inheritance means that there's only one parent class for every class. You can't have two parents. What about C++? Yes, C++ supports multiple inheritance, right? In C++ you can go phablet, colon, phone, comma, tablet. And that means it inherits from both of those classes. Does everybody understand that? But this can't be done in C#. Now we might take something else, like a Surface, right? Which is this Microsoft thing, you know, the Microsoft Surface, which is out there. So we have a Surface, right? And a Surface is like a cross between a tablet and a laptop. So that's another example of what we call multiple inheritance. And it's something that can't be coded in C# or Java, but it can be coded in C++. Alright, that's called multiple inheritance. However, something that both Java and C# has that C++ doesn't have is this concept of an interface. Alright, so we're already used to this idea of an abstract class. What's an abstract class? Can't be instantiated. You have to create a subclass of it if you want to create an instance of it. What's an abstract class used for usually? Huh? Do you remember the multi-choice quiz? There was one option on the multi-choice quiz about an abstract class. It's used to guarantee that a class implements a certain set of methods, isn't that right? If you know that something extends an abstract class, then it absolutely guarantees that it has an implementation for various different methods, right? An interface in C# is similar to an abstract class. Okay, actually I'll write these up as just two columns here, right? An interface, you guys should be taking notes. And an abstract class. An interface is similar to an abstract class, so it's used to do the same kinds of things. In other words, to guarantee that a class implements a certain API. So guarantee, right over here, TEE, a particular API. Yes, an interface and an abstract class. If you implement the interface, or if you extend the abstract class, you're guaranteeing that a class has a certain set of methods on it, right? Some other things about interfaces and abstract classes. An interface can have a constructor. You don't know this already, but what would you think? No, can't have a constructor. No, but an abstract class can have a constructor. Can it have fields?
Yeah.
An interface can't have fields, but an abstract class can have fields. Can it have methods which are implemented? Method bodies, interfaces can't have method bodies, abstract classes can have method bodies. So you can see what the differences between them straight away are, right? So an interface is just a set of methods that a class needs to implement if it implements the interface. Whereas an abstract class is an actual real class. It can have methods, it can have constructors, it can have fields, it can have statics. Another thing that interfaces can't have is statics. ICS. Interfaces can't have statics, abstract classes can't have statics. So you can see that an interface, the only thing that an interface does is it guarantees that a class implements a certain API. And that's the difference between an interface and an abstract class. So you can extend only one abstract class, but because an abstract class doesn't have, or an interface doesn't have constructors and fields and method bodies, you can implement as many interfaces as you like. So this is how you can do things like saying that a phablet has some characteristics of a phone and a tablet, and that you implement an interface for tablet and for phone. So that's an interface, right? Interfaces are always used to do this, to guarantee that a class implements a certain API. And that leads us into this idea of programming by contract. Okay? So programming by contract means that you basically decide in advance what API something needs to have implemented, and you can write an interface for it, and you can have different implementations for that interface. So if I was to think, we're going to do an example of this. We'll do an example of a logger class, which implements a logging interface, right? But you know, this is the same idea, like if you want to think about how a graphics card works, right? So you've got an ATI graphics card, you might have an Intel graphics card, you might have an NVIDIA graphics card. And they all implement the DirectX APIs and the OpenGL APIs, but they all do it differently. Do you understand? But there's a contract between the graphics card and the operating system. The graphics card says, I need to be able to call this method on you to draw something to the screen. And then the underlying hardware does it differently depending on whether it's an Intel or an ATI or an NVIDIA graphics card. Do you understand that idea? Mm-hmm. Alright, so that's the idea of a contract. So there's contracts, and interfaces are used to implement design by contract, right? So we'll do an example of an interface in C#. So the example I'm going to do with you guys this morning is a logging interface, right? So I've written this up, but what we'll do is I'll create a new project and we'll code it up from scratch here, right? Close that operator overloading down. Restart this thing here. Okay. Let's create a new C# project here. Console application. Delete meet interfaces. Okay. So the first thing I'm going to do here is I'm going to decide what is the contract that the classes are going to need to implement. And the contract is the interface. So I come over to my project here, and right click on my project, and I'm going to click add a new item, and from the list here I'm going to choose a C# interface instead of a class. And it's a kind of a naming convention in C# that interfaces begin with the character I. So I'm going to call this iLogger. Oops. iLogger. So, okay, what can you see here? First of all, instead of class, you use the keyword interface. And the same thing applies here. I would always put the word public in front of that. Otherwise, it's only visible within the namespace. Right. Now, remember I said here, can't put a constructor, can't put a field, can't put method bodies, can't put statics. The only thing we can put here is the API, the methods. The other thing as well is, in C#, you can't make any of the methods private. They have to be public. Alright, when you're doing an interface. Sorry, by that I mean you don't put the word public or private in there, it's just defaults to be public, right? So we want a method here, void log. Alright, and that's my interface. So this interface has only got one method on it, which is called log. And we'll implement 3 different versions of this log in different classes that implement this interface. One that logs to a file, one that logs to the console, and one that just keeps track of them all in a list. Alright, all the messages that are logged. So we're saying now that in this program there are going to be other classes which can log things. And you just pass in the message, and anything that logs has to implement this method log, which takes a string. Alright, so that's the logger interface called iLogger. So now let's make the first implementation of this method, which is one that just logs to the console. So I'm going to right click on this here, and I'm going to click on add class. This class I'm going to call console logger. Logger. Right. So there's console logger, and in C#, how do you say this class implements an interface? Just go the same as you do with inheritance, colon iLogger. Alright, same as with inheritance. But if you wanted to say it inherits from a base class, plus it implements various different interfaces, you just use comma, and you can list all the interfaces that it implements there and separate them with commas. So you can have multiple interfaces, and you can still extend a base class if you want. Alright? So this means that this class has to implement the iLogger interface. Now if it has to implement the iLogger interface, then when I try and do a build here, straight away you get a compiler error. So it's saying console logger does not implement interface member log. So it's guaranteeing the program won't even compile. If I'm saying that this implements that interface, it guarantees that it has to have that method, and otherwise it won't compile. Do you follow? Alright. So we have to put a method on here. Public void log. Interestingly, we'll do a bit of Java programming next week, and you'll see that the IDE Eclipse, which we use for Java, is able to fix these errors for you automatically. It's very good. It'll write the code for you practically. So, GUSSAE. Alright, so this implements the logger interface, and then we want to say, what's it going to do? Console dot write line. The message. Alright, so that's the first class that implements the interface. Now this is going to build. Okay, let's make another version of this, which does some completely different kind of logging. Let's get it to log to a file, right? So I'm going to right click on this, I'm going to click add, new item, class here, and this class I'm going to call this file logger. And this file logger class is also going to implement this interface. And because it implements the interface, I have to guarantee that it has a public void log method on it. Now, this is an actual class. I'll make this public as well. This is an actual class, not an interface. So I can put a constructor in here and I can have fields and properties and everything, right? So the field that I want, I'm just going to double check my solution here. For the file logger, yeah, file name and a stream writer is what we want. Okay. So first of all, this is going to log to a file, alright? Instead of logging to the console, this is going to log to the file. So, so it's going to log to that file. And then it was called a system.io. What was it called? A buffered writer, was it? Oh, stream writer, was it? Oh yeah, stream writer. Alright. Okay, so we'll make our constructor here, and in the constructor we'll create that that writer. Public file logger. Writer equals new stream writer. You pass in the path and whether you want to append to the file. So the path we want is file name. The second parameter for this, you notice I'm just using code completion here to figure out the different versions of this constructor. The second version of this allows you to pass a boolean in to say whether you want to append to the file if it already exists or overwrite the file if it doesn't exist. So I'm going to pass in true for that, and that's just going to it's just going to append to the existing file if it finds a file there already. And then the writer, I should do writer dot print line. Sorry, writer dot write line, isn't it? Yeah. Yep. Date time. Date time is the C# class for doing everything to do with dates, and you can format dates to different locales and things using that, and you can extract things like you can add and subtract dates, you can extract the milliseconds, the seconds, various things like that. So date time dot now is a static on date time which gives you the current date and time. And it will convert it to a string because this method takes a string. So I'll pass in a /t tab for that. Alright, so this is kind of a more useful way of logging. So now what I'm going to do is I'm going to write the message to a file and I'm going to put the date and timestamp in there as well with the message. Does everybody follow what I'm doing there? Alright, so now I have two different ways of logging. Right, I'll just build that, make sure everything builds succeeded, right? So I have one way of logging which just writes things to the console. I've got another way of logging here which is going to write things to a file. So let's make use of a class. Let's add a class now that makes use of logging. So I'm going to click add new item here. Just for the hell of it, I'm going to call this test class. It's just an ordinary C# class, right? Now, we've got two ways of logging. This class doesn't really care how the logging is done. It just knows that it needs to do logging, right? So instead of having an instance of the file logger or the console logger, it's just going to have an interface called iLogger. Alright? Does everybody see that? Understand? So it doesn't matter which type of logger it is. It just knows that there's something here which implements the iLogger interface. I'm going to make that private. And then I'll right click on this and I will make a property for it. So I'm going to get this class just to do some random stuff and write some stuff to a log file, okay? So public void do stuff. Right, I'm just going to get it to write a certain number of lines at random to the log. How do we generate a random number in C#? Use the random class, alright? And the normal thing here is to seed it. date time dot now dot milliseconds. So that's the usual way that we create a random number here. And then I want to count equals or dot next, which is going to give you the next and then there's a version of this that takes the max value. So this will give you a number between 0 and some maximum value. In fact, you can do min value and max value. Let's do 1, 1,000. So we'll get a random number between 1 and 1,000 there. Alright? At least 1 and no greater than 1,000. So I just go, what do they call it? logg, logger.log. And a message from Alright, so yeah, the message here is that it doesn't care how the logging is done, but there's something that implements the iLogger interface, and I'm going to send this a message. Now I have this contract between this class and the class that implements the iLogger interface, and it can do whatever type of logging I've set it up to do, right? So over here then, I can create an instance of my test class. I need to give it a logger, otherwise it won't work. Test class.logger equals new console logger. And then test class.doStuff. And then I can go test class.logger equals, and I can give it a file logger. Alright, so the whole point is here I'm changing the behavior of the test class by changing the class which is doing the logging. Do you see that? So it's going to do something different in both examples here, and I'm just basically giving it a different logger in both cases there. Everybody see that? We run it, see what happens? Oh, hang on, I forgot to do one thing. In the file logger, in fact, I'll just leave it. Well, how did I fix this? Just forgot to do one thing here. Has anyone done any files in C#? The file will get closed automatically. I did try putting a close in the destructor, but it seemed to have gotten closed already at that stage, so I'm not quite sure where you need to close the file. But yeah, I guess you should close it somewhere. One thing I noticed was it didn't actually write the thing until I went file writer.flush. What does flush mean?
Empties the buffer.
Empties the buffer, right? I noticed that it didn't actually write to the file unless I put that call in there. I'm not quite sure why.
Usually,
it's not because you didn't have a using system.io as your.
No, that's nothing to do with it. That's just
because when you create a stream reader, you used use system.io stream reader. You didn't use it for writer.
Yeah, so that's the only. Okay, so that's a good point, right? So the only thing that does for you, if you change your code like this. That's only a compile time thing, right? You can go using system.io
Get rid of the IO.
and then you can just get rid of this here. That's the only thing that gives you. Alright, so it's actually just a compile time. That doesn't actually change it doesn't actually change anything about the program. This will generate exactly the same program in both things. All that is just it's just telling the compiler that whenever you see stream writer, it could be in that package. So that's all the using does there. Alrighty. Anyway, I'm not quite sure why, but you need to put the flush in there, otherwise it won't work. Okay. So we'll run the program, see what happens. Here is my. I'll run it through once, all the way through to the end. Here we go. F5, and then if I find that folder. There's out.txt, hopefully, yeah. There's all those messages, those logged messages there, right? Now, I just want to be clear about what's happening here with the interfaces. So let's jump up here to test class and set a breakpoint here. So you can see the two different versions of that method getting called at different points, right? So if I hit, in fact, maybe a better thing to do is to set a breakpoint there. Alright, so I hit F5. So first time around, if we hover over logger, I will see logger is an instance of a console logger. Alright, it implements the interface. You don't need to change the code. The contract is the same for both of those. So we get the count. We come in here. If I press F11, which is step into, I will see that it's console logger that gets called here, because that's what it is. It is a console logger. Alright. And then I'm going to hit F5 to let it run through. Second time it comes in here, if I hover over logger, logger is now an instance of a file logger, but it implements the same interface, so the program doesn't need to be changed, but it will do something different this time around. Even though it's the same method, jump in here and we see that it's actually the file logger that gets called. See that? Does everybody understand what interfaces are? An interface is another name, or it's often described as programming by contract. Right, because you decide what the contract is between two classes, what API that employs, and then you can have as many different implementations for that contract as you like. So long as it implements the contract, you can plug in a different method, or a different class at runtime. Everybody follow that? Will you try and write another implementation of that, and instead of writing it to a file or writing it to the console, store all the message in a list? Will you try and do that just on pen and paper for some practice? And then we'll do a version of that. Just store them all in a list of strings. So, I want to do a completely different form of logging in this one, but I am also going to implement that contract so that any class that needs to do logging can do logging in this way as well. So, I'll just click Add New Item, and I'm going to call this a list logger. To say that list logger implements the interface, you just go :ilogger. And then it has to implement the log method. So what I want to do in list logger is just create a list of strings. And I just want to add them to the end of the list of messages. That's it. So now you can plug in the list logger wherever you make use of the iLogger interface. So over here, I could set the logger to be the list logger. And when I get to here, if I hover over the logger here, I should see that in here I've got 110 messages, and there's all the messages stored in a list now. So I've got three different implementations. One that just prints to a console, one that logs all the messages to a file, and one that just stores all the messages in a list. But they all implement the same interface, so they're all, you can substitute one in where another one goes. Is that okay with everybody? Does anyone want to ask any questions on how interfaces are implemented in C#?
What's the benefit?
What's that?
What's the benefit?
The benefit is that it's designed by contract. So there are loads of examples, and in fact there's a million different interfaces that you can implement in C# and that you have to implement in different contexts. For example, if you want to, there's certain operators, even an operator overloading. if you implement the double equals, in other words, equals equals operator, you have to also implement an interface. And one of the methods on it is you've also got to implement a method called dot equals, the dot equals method. There's loads of them. It's used a lot in event handling in Java. And in fact, you'll see it next week when we do some Android programming, that if you want to say this particular class responds to a button click, you implement the button click interface. And then that's the way it's done. So it's used all over the place, by designed by contract. Yeah?
And you make an interface, can you use it to make an abstract class, which you use to make a class?
No problem. An abstract class can implement an interface. That's no problem. Yeah?
Can you have optional methods?
No. Once you set up an interface, the class, if you implement that interface, you have to include all of the methods in the interface. Otherwise, the program won't compile. So like I say, it's a guarantee that the program implements a certain set of APIs. Yeah?
Is there anything interfaces can do that abstract classes can't?
No.
So...
Oh, sorry, there is one thing. Yeah, you can implement multiple interfaces, but you can only extend one abstract class. You follow?
Yeah.
So if you extend an abstract class, that means you can't extend anything else, you know? So you can't implement this sort of multiple inheritance thing with abstract classes. Because, you know, if a phablet extended a phone, then it can't extend a tablet. But if tablet and phone were interfaces, you could implement as many interfaces as you like. Because they're just APIs. There's no... What's that?
You can't implement an abstract class and an interface in one class.
You can, definitely,
okay.
yeah.
Okay.
You can, well, the terminology is that you extend an abstract class, but
Right.
you implement an interface.
But yeah, you can do both of them on the one class.
Definitely, yeah. Because you can only extend one class, right? You can only have one base class, but you can implement as many interfaces as you like. And you can understand why that is the case, right? The reason why this becomes complicated, in phone, for example, say phone had a field on it called screen size. And this also had a field on it called screen size. Right? The problem with multiple inheritance is phablet now has got two screen sizes. You see that? Because it gets one from here and one from here. And this is exactly what happens in C++. You actually get two versions of screen size. And you have to use what's called the scope resolution operator. So you go phone, : screen size to disambiguate between the two. And that's exactly the term. It's called disambiguation, and in C++ that's called a scope resolution operator. It doesn't exist in C# or in Java. But that's why, you know, because you can't have this with interfaces, you can implement as many interfaces as you like. It doesn't matter if you've got the same method in multiple interfaces. There's no conflict. You never get a conflict. Is that okay with everyone? Should we take a 10-minute break then? Alright, let's do it.